Hello, my Calc 3 student. Today we're doing some review about material calculus 3, and I solved for you a couple of examples what was something similar you have in your final exam. First, sketch the curve represented by some parametric equation and write corresponding rectangular equation. Let's go. We have x equal 2 plus 5 cosine c, y equal 3 plus 2 sine c. And the question first asks us sketch the graph, then doing something. But because here we have cosine and sine, and if we plug in some angle, it will be not so useful numbers. Maybe first we write as corresponding rectangular equation and then sketch the graph. Okay, for first we solve this equation, each of them, and cosine c will be x minus 2 over 5, and sine c will be y minus 3 over 2. Here we need to remember trigonometric identity. Tell us sine squared t plus cosine squared t equal 1. And plugging for this identity, this means one more time I write, this will be more useful. Identity we use what is comfortable for us. It will be maybe secant, maybe tangent. It depends what you have in the euro. Here we have it. This is very simple example. And plug you have x minus 2 square over 25 plus y minus 3 square over 2 square, who is 4, equal 1. You can see this is ellipse. And what kind of ellipse it will be? Center is not origin. Center is moved to 2, 3. Okay. Let's go. This is x-axis. This is y-axis. Y. Plugging, for example, y equal 3. What you have? This situation. If y equal 3, this means your second fraction equals 0, and x need be equal 7, or negative 5. This means negative 3. Okay. 1, 2, 3, negative 3. 1, 2, 3. Mm, 3, 5, 7. Okay. Let's go x equal 2. This means you have first fraction equal 0, and then is y need be equal you need be equal 1. X equal 2, y equal 1, or x equal 2, y equal 5. 3, 4, 5. I think it's 5 will be. Okay. And this is give us oh my god. I think it's this is will be oops. This is will be a little bit better. Okay, and now we need orientation. For orientation, I use table. Let's go see x and y. For orientation, I need only 2 points, and I plug in something very simple. 0 and pi over 2. If t is 0, my x will be 7 and y will be 3. If t is pi over 2, my x will be 2 and y will be 5. This means I have from here and go to there. Okay, this is my orientation. Okay, question number 2. Here we need found set of parameter equation of the line passes through the given point and parallel to given line. It can be parallel, perpendicular, something like this, but here example we have given point. This is question number 2. Given point, let's go, it will be something very simple, 1, 2, 3 for example, and parallel to the line. I write this way, x equal to y equal negative z. But question, I need to write equation line to parameter. This means I need to use some parameter c and I need 3 equations. Okay. First rewrite our equation, our line like parameter. Let's go x equal t. It's simple our situation. Then y will be 1/2 t because y equal 1/2 x, and z equal minus t because z and x is opposite. Here we have what you know about vector, direction vector. Direction vector, this line, it will be direction vector. It will be vector with coordinate 1, 1/2 and -1. And because our line is parallel given line, this means these two lines have same direction vector and only use point 1, 2, 3 with coordinate 1, 2, 3. We can write new equation. This means answer for our question 1 plus t, y equal 2 plus 1/2 t, and z equal 3 minus t. This is our answer. Okay. Second question. Third question. Found equation of the plane contains to the given line. Okay. What kind of line we have? It's question number 3. Let's go, x equal negative t plus 1, y equal t, and z equal t minus 1. This is line number 1, and line number 2, it will be x equal negative 2t minus 1, y equal t plus 1, and z equal t plus 2. Thinking here, what kind of problem we have here? We have two lines, and if you checking your direction vector, for first line it will be -2, 1, 1. For second line, it will be -2, 1, 1. This means we have two parallel lines. What I say it's problem, because if you want to found, if lines wasn't be parallel, you can easily find a vector will be perpendicular to given vector and then use this vector for found equation, our plane. But because this is two vectors parallel and vector perpendicular to parallel vector is infinity, you know, it's a lot. This means we cannot use this fact. How we working here? Take it some 3 points from our two line. But one more time, we have problem, but we have solution. Because two parallel line, we can build only, for two parallel line, you can build only one plane. Okay, what we're doing here, we'll take it some points, 2 points from first line, for example, and 1 point from third line. Oh, first I take it something very simple. Let's go t equal 0, for example. This means I have point A with coordinate 1, 0, negative 1. Point B, let's go t equal, I don't know, t equal 1, for example. I have negative 1, 1, and 0. I try to take it something more similar as possible. And here is t equals 0 for second line. It will be point negative 1, 1, and 2. Okay. And then I found two vectors who stay in the our plane. Okay, what this will be? Let's go its vector A, B. It will be negative 2, 1, 1. Vector, let's go B, C. It will be negative 1, subtract negative 1, it will be 0. 1 minus 1, it will be 0. And here is only 2. I took it something else. Okay, this is two vectors, two segments who stay in the our plane. We need vector perpendicular, both of them. This means vector u, we need found vector u, whose will be perpendicular IB, and u perpendicular BC. Okay, this means we need found cross product. I, J, K, and this is your choice what you write is first, what is right is second. 2, 1, 1. Here it will be 0, 0, 2. I, 1, 0, 2, minus J, negative 2, 1, 0, 2, and plus K, negative 2, 1, 0, 0. You can see it will be 2I, negative 4 and plus 4J, and plus 0K. Okay, this means vector u have coordinate 2, 4, 0. Then take it one of your points, what is more comfortable for you. For example, point B with coordinate negative 1, 1, and 0. We can build our equation, our plane. It will be twice x subtract negative 1 plus 4 times y subtract 1 and plus z 0 times z subtract 0. We have 0, and this is give us 2x plus 2 plus 4y minus 4 equals 0. X plus 2y equal, I think it's 1. This is our answer. Okay. Next question. Question number 4. Here, found the unit tangent vector for the curve. Okay. Given curve, given point, and let's go our curve. It will be 2 sine ci plus 4 cosine cj at point c equal pi over 6, and we need found unit tangent vector. How you remember unit tangent vector? It will be derivative r divided by norm this derivative. Or you can write speed divided by velocity. It's all of them the same. Okay. First found derivative here, r prime t. It will be derivative sine. This will be cosine. This means 2 cosine ci. Derivative cosine negative sine minus 4 sine cj. Now we need found norm this vector. Square root. Square first coordinate give me 4 cosine squared c. Square second coordinate give me plus 16 sine squared c. It will be 4 out. It will be 2. Here we have cosine square c plus 4 sine square c. Well, it's your choice. For example, cosine square plus sine square equal 1. I can rewrite like 2 square root 1 plus 3 sine squared c. This means tangent vector, it will be cosine c over 1 plus 3 sine squared c I minus 2 over 1 plus square root 1 plus 3 sine squared c g. Tangent vector, unit tangent vector we found, and then depend what kind of point you have, you need plugging, and you have c from pi over 6. It will be when I evaluate, okay, cosine pi over 6, this will be square root of 3 over 2. Sine, it will be 1/2, this means 1 plus 3 to 4th I minus. Okay, guys, here I forgot to write sine c. Minus 2 times 1/2 divided by 1 plus 3/4. Here's j. Here will be square root of 3 over square root of 7I. Okay, maybe I write this here. It will be square root of 3 over square root of 7I minus, here is 2 over square root of 7g. We not only found unit tangent vector, we're plugging exactly point, and then we can. Okay. Number 5. Found limit. Here you have function x, y approach to 0, 0, frag fraction, y plus x to the power e to the power negative y squared divided by 1 plus x squared. Easy as possible. Plugging your 0, 0. You have 0 in numerical and 1 in determinant, which will be 0. Okay. Number 6. Found all first partial derivatives for function x, y, z to x z square plus 6xy z minus 5xy cube. I think it's no problem solving here. Only every time don't forget where your variable is. Found derivative respect x. Whereas you have x here, here, and there. This means derivative will be 2z squared plus 6y z minus 5y cube. Derivative respect y. Where is our y we have? In the first term we don't have. Second term we have y there. And third term we have y there. Okay. What will be derivative here? From first term is 0. Or second term it will be 6xz. And here is y is power 3. This means minus 15xy squared. Okay. And last one, derivative respect z, where you have z for first term and for second term and not for last one. This means here we have f for z equal, here is z squared, this means you have 4xz, here is z to the power 1, this means only plus 6xy. That's it. Okay, next question. Question number 7. Found directional derivative of the function and given point and given direction. Okay, what we have here. Let's go. Our function is f is 1/4 y squared minus x squared. Point P is 1/4. And direction vector V is 2i plus j. When we talk about directional derivative, how you remember, first we checking our vector. How you remember, vector need be unit. This means norm, this vector, it need be 1. What about vector V? Vector V, we have square root. 2 squares will be 4, 1 square is coordinate j, it will be 1. This means we have normal square root of 5. And we need new unit vector who have same direction. It will be 2 over square root of 5i plus 1 over square root of 5j. Now we're ready for found directional derivative. Found gradient function f, it will be derivative for x, it will be minus 2xi. Derivative for y is will be plus 1/2 yj. Here's you have two ways. You can found dot product gradient in U, then plugging, or you can first plug in, then found. I think we plug first. Gradient f for point P, this means from point 1/4, you have minus 2i plus 2j. And derivative your function for respective vector u, direction vector u, 0.14 will be dot product minus 2i plus 2j for vector 2 over square root of 5i plus 1 over square root of 5j, who give us definition dot product is some coefficient corresponding coordinate. This means we have minus 4 over square root of 5 and I think we have plus here, yes, and plus 2 over square root of 5, it will be minus 2 over square root of 5. Great. Okay, next question. Here we need examine our function, multiple variable function for relative extrema and saddle point. Let's go, we have function f x y, it will be x squared, this is question number 8, okay, right here, x squared, so I squared minus 16x minus 16y. And here first we need found critical point. Critical point is point where all first order partial derivative equals 0 or first order partial derivative does not exist. Because we have polynomial here, this means all exist, only we can check in equals 0 or not. Derivative respect to x's will be 2x minus 16, partial derivative for y it will be minus 2y minus 16, 2x minus 16 equals 0, minus 2x y minus 16 equals 0. Solve this system, you have x equal 8 and y equal negative 8. This is our critical point. Now we need checking. Second derivative, okay. X give me only 2. y give me negative 2. And fxy mixed, it will be 0. Now I'm counting z, who is fxx, fy, y minus fxy, oops, square. Because second order derivative all constant, we don't need plugging point, we only evaluate, this will be negative 4. Because d is less than 0, this means our point with coordinate 8, negative 8 is saddle point. Okay. Number 9. Sketch the region whose area is given by the iterate integral, then switch order of integration and show that both of order yield the same area. Okay, let's go. We have some integral from -3 to 3, from 0, 9 minus y squared dx dy. What does integral show us? Show x changing between 0 and 9 minus y squared, and y changing between -3 and 3. Okay, try graph this region, and what we have, x, y, let's go, this is equal 9, and this is 3 and -3. Curve x equal 9 minus y squared, it will be this kind of, it's like parabola, and then x change from 0 to 9 minus y squared. This means x change from 0 to here until curve. Because y change from -3 to 3. You see? X from 0 to here. Okay. How you can write how it's differential, different order. Okay, let's go x equal 9 minus y squared. It's mean y squared equal 9 minus x, not x minus 9. Okay, 9 minus x, and this mean y need be stay between these two curve. It's between minus square root 9 minus x and square root 9 minus x. And this is how changing y, and how changing x. X change from 0 to 9. X change from 0 to 9. Okay, and this means if you change in order, you have integral from 0 to 9, integral from from minus 9 minus x, square root, and square root 9 minus x, and here is dy dx. Okay, how it's solving, it's your choice. Well, for example, I solve here. It's absolutely same, it's no problem with solving. It's mean, oh, okay, solve this one, what we have here. It will be, okay, integral from 0 to 9. This will be y, and you need plugging. Go. 0 to 9. Here will be root minus negative root. It will be twice square root 9 minus x dx. Okay, x 1/2 power, this means 3/2, 2 9 minus x power 3/2 divided by 3/2. And remember, coefficient x is -1. This means here you have minus, and from 0 to 9. If you plug in 0, it will be 0. If you plug in, just a moment, if you plug in 9, it will be 0. If you plug in here, it will be plus 4 thirds, because it's negative, this means plus. 9 power 3 halves. He's give us 327, 9, this means 36. Okay, we come back with our old, and I write what happened if I have different order. Okay, I'm checking here, clear here, and we have integral there. It will be from negative 3 to 3, x from 0 to 9 minus y square dy. It will be integral from negative 3 to 3, 9 minus y square dy, who is equal 9y minus y cube over 3, negative 3, 3. It will be okay. It will be 27 27 over 3, it's minus 9, minus 27, it will be plus 27, and minus 9, it will be 18 twice 36. Okay, great. And I think now we're doing one more. Question number 10. Evaluate the iterate integral by converting to polar coordinates. I have integral from 0 to h, integral from 0 to x, square root x squared plus y squared dy dx. How you remember you rectangular integral you convert to polar coordinate. If you have some border one, you can easily use polar coordinate, or if you have function. Here is function. It is simple because how you remember square root from x squared plus y squared, it will be exactly r. And now question what happened with our border, trifound region. We have y change from 0 to x. This means you have line y equal x. Okay, y equal x. And x change from 0 to some h. This means here we need this kind of triangle. Okay, what we have here? Because y equal x is line, this means our angle theta is it theta changing from 0 to pi over 4. And only question about how changing r. Okay, y is y change from 0 to x. Okay, and this means I need not y, I need, sorry, x equal r cosine theta. This means r changing from r equal x divided by cosine theta, right? Oops. And now we have x change from 0 to h, 0 to h. This means r change from 0 to h over cosine theta. This is hardest part for this integral, because all others very simple. And our integral will be theta change from 0 to pi over 4, r change from 0, h over cosine theta. Inside integral we have r, who is come from square root x squared plus y squared, and because we move to polar coordinate system, we have one more r. This means r squared dr d theta equal. Here I have 0 pi over 4. R squared give me r cubed over 3, 0 h over cosine theta d theta. It will be, if you plugging and if you remember cosine, it will be 1 over cosine, it will be secant. This means here I can rewrite like 1/3 integral from 0 to pi over 4. I have h cube and divide by cosine cube, who is mean multiplied by secant cube theta d theta. Okay, we have h cube over 3. Here we need to remember what is integral from secant cube. Okay. Okay, guys, because you have open book final, it's not depend I tell open book or not. I know my student open, but it's okay, no problem. This means you can use appendix B and write this is integral will be product secant tangent theta over 2 plus 1/2 natural logarithm secant plus tangent. Okay, this is absolutely. And we need plug 0 pi over 4. Okay, it will be h cube over 3. And remember, secant pi over 4, it will be square root of 2. This means here we have square root of 2 over 2, because tangent is 1, and plus 1/2 ln. Here we can use print the square root of 2 plus 1. This is our final answer. Okay. Question number 11. It's very simple question. Here we need found Jacobian if your x is uv and if your y is v over u, and Jacobian you need found z xy z u v. Okay. Only remember definition. What is Jacobian? This situation tell us. We need found determinant. First row it will be dx du dx dv, and second row dy du dy dv. plug here. Derivative x for u we have v. Derivative x for v we have u. Derivative y for u we have minus v over u square. Derivative y for v we have 1 over u. V u minus, and because it's minus is plus, v over u. We have twice v over u. Okay? Or maybe one more question, and then we make it some break. And okay, I need to integrate double integral from some region R, and integral it will be 6x squared dA, whereas region is region bounded curve line, I don't know how it's still. Okay, y equals 0, y equals square root of x, and x equal 1. First we build our region, right? What we have here? We have y equals square root of x. Here let's go 1. And this means we have something like this. And easy way solving this integral. Let's star here. This means I have star there. Equal integral y changing from 0 to our curve. 0 to square root of x. X changing from 0 to 1. 0 to 1. Function inside is not changing, 6x squared, and then dy dx equal integral from 0 to 1, 6x squared y, where is y from 0 to square root of x dx? This is give me 6 integral 2 plus 1/2, it will be x power 2 and half, it's give us 5 halves dx from 0 to 1 give me 6, new power x, it will be 7/2, divide by 7/2, 0, 1, it will be 12 over 7. We're done. Okay. Okay.